Hello, good evening and welcome to EU Training's online webinar, A Beginner's Guide to the EPSO Numerical Reasoning Test. Before we begin, just to introduce myself, my name is Robin Bott and I am a Chartered Occupational Psychologist and I specialise in assessment methods, particularly verbal, numerical, abstract reasoning tests, situational judgment tests, those sorts of things. So I've written hundreds of these types of questions before. I've also worked on several hundreds more. I've provided all sorts of training in the design of these, in the use of these, and in how to perform to your best in all of these different types of psychometric assessments. I'm going to be supported tonight by my co-host Lenka, who is going to be available for technical queries. The overall aim of the EU training sessions is to help you perform to your absolute best when you take the various reasoning tests that EPSO require you to take. So tonight's focus is going to be on numerical reasoning. Now we're going to start with a 30-minute starter session. That's going to be recorded, so there's quite a lot to get into in the 30 minutes. So if I'm a little bit quick in places, don't worry, there's going to be a recording and you're going to have access to that afterwards as well. So you can always rewind and listen to some of the more the trickier parts. This session is going to be very theory focused, so we're not going to be working through full questions. I'll have some questions on screen, but we won't be working out the answers in full. I want to give you an overview of the types of questions that you're going to get and how to think through them. It's not about maths basics, so I'm not going to be teaching you, for example, how to multiply or how to add. Those are skills that you can pick up elsewhere if you need to work on those. What I'm going to be doing is focusing very much on the types of numerical reasoning questions that you're going to get during your assessment. And this is designed to be followed by a pro session. Now you have to sign up especially for the pro session, and that will start shortly afterwards. And that pro session, that's designed to put learning into practice. So a lot of the different techniques we've learnt that we're going to learn in the next half hour, we're going to have questions based around those. That's also going to be more interactive as well. So as I said, this is going to be very much me talking about theory for half an hour. But if you attend a pro session, you'll be able to ask specific questions. If there's anything you find particularly difficult, we'll explore that in more. We can explore that in more detail. You can ask me questions, and we'll also have that consist of, I believe it's 8 different numerical reasoning questions that cover a range of the concepts that we're going to be discussing in the next half hour. So, as an overview, the EPSO Numerical Reasoning Test is you have 20 minutes to answer 10 questions. So that averages out at 2 minutes per question. So when you're working, when you're practicing yourself, you can time yourself at that. In the pro session, I'm also going to allow 2 minutes per question. Now, obviously, when you're working in the exam itself, you might get ahead of time, you might get behind time. But 2 minutes is a good approximation. It's how long you should be, or the time you should be beating for each question. And you're aiming for half marks overall. For the actual exam itself, you can't take anything into the exam room with you, but you will be provided with a small whiteboard, and that lets you take notes and write things down as you're going along. And you'll also be provided with either a physical or an on-screen calculator. So you are allowed to calculate these. It's not a test of your raw additions, multiplication skills. It's also very much skill-based as well, so you're not expected to know anything apart from kind of the core concepts, how to multiply and that sort of thing, in advance. So before we begin, I want to give you a brief overview of a numerical reasoning question. So we're not going to solve this now, but I want to show you the parts the question comprises. So firstly, you'll have a question itself. Then you'll have some sources of data. So in this case, we have 2 sources of data. You might have 1 or 2. And then you'll have a series of answer options. And your task is merely to pick which of these 5 answer options is correct. Just wanted to give you an introduction because when we start talking about the concepts behind these questions, I want you to know kind of what it will look like in practice. So this is the model that we're going to follow for solving numerical reasoning questions. So we're going to talk through this model this evening. We're going to start by interpreting the information. So there'll be information on screen. What can you get out of it? What do you need to know? Then we're going to talk about numerical reasoning. So that's the part where you figure out what exactly you have to do with that information once you've identified it. And then we're going to talk about calculation and estimation. And these are two techniques that can be used interchangeably. Sometimes you'll use calculation for an answer, sometimes you'll use estimation, and sometimes you'll use a bit of both. But both of them are very important skills, and if you can master both of those, then you're going to be in a strong position. So I'm going to start by talking about the interpretation of information. So this is about understanding what it is that the tables, the charts that are given are telling you. And it's about understanding which parts are actually relevant to the question being asked. You're going to usually be presented with a vast array of data, so kind of complex tables. And typically you'll only need to use a portion of those. So you'll only need to use one specific column or maybe a row or maybe a couple of rows. So honing in on that key information very quickly is very important. The table I showed you beforehand, the question I showed you beforehand, there are a couple of tables, so thinking about how the different elements interact as well. So if you have a table and a chart, how are those interlinked? Are you going to need to use both of them? Do you only need to use one? Is one of them a complete distraction? Also you should pay attention to the scale being used. So often you'll be given data and you'll be told it's in the thousands or in the millions, and you've got to be aware of that, because that can mislead you if you're not fully aware. The final point to be aware of is sometimes the question itself might add in additional information. So just because you fully understand, you fully comprehend the graph given to you, it doesn't mean that you've got your answer. You might need to bring in something from the question, and we'll have a few examples of that as we go along as well. So going back to this example, things that I might think about are, how are these two tables related? Well, for example, we can see France, Germany, Italy, UK, we can see the countries are the same. They're both talking about things in thousands, so that's an important scale point. Might note that the graph doesn't start at 0, so that might be an important thing to be aware of. Another thing to be aware of, I guess, is that these graphs don't give you exact numbers. So we have exact numbers here, or very, very precise numbers at least. Here the numbers are a bit looser, so this might be about 27,500, but we don't know that for a fact. And why that's important is it tells me that maybe estimation is going to work a lot better than exact calculations. If I can't take away this exact number, then how am I going to work out a precise calculation? So, and I've already pointed out that these scales are both in thousands, so this isn't 61,000, it's actually 61 million. So here's another example of some information, and we've got some potential questions that might arise from it. And this is to illustrate that, I guess, a typical question is not going to require the whole table. So we've pulled together some of the sorts of questions that a numerical reasoning test might ask from this. And we've shown what specific data relates to it. So what is the average temperature across all 4 quarters in Belgium? Well, that would be got from the... Firstly, we identify the Belgium row, or the Belgium set of cells, and then the average temperature. So this is the information we need to use to work that out. A similar thing can be done with the rest of the questions. So what is the total rainfall across all 3 countries? Well, we know it's not now limited to one of these countries, but it says for quarter 2. So we're looking at the rainfall for quarter 2, and it's a total. So let's have a look. This is the data that we would use for this. What is the difference between total rainfall in Austria and Belgium? So again, we're looking for the relevant information: Austria rainfall, Belgium rainfall. And we're kind of treating those as separate things as well. So you're going to need to work this out, and then you're going to need to work this out. The final question is what I talked about when I mentioned that sometimes additional information will be included in the question itself. So the total rainfall in Poland is 18% lower than Czech Republic. What is the total rainfall in Poland across the whole year? Well, if you just had the second part of that question, you'd be a bit panicked because you'd look over and see there's no Poland here. But you can work it out by working out Czech Republic's total rainfall and then working it from there. So the key information here is this row of information plus this fact that Poland is 18% lower. So we're going to move on now to numerical reasoning. So now that you know what information, now that you've identified the important information, the next step is to figure out what to do with it. I expect some of you might even have been thinking about that already while we were working through the previous questions. But there's a series of skills that are skills and slight knowledge that it's important to know, and there's a series of things that it's not important to know. So things you'll be asked are around addition, so totaling up different sets of values, subtraction, so working out the difference between them. Multiplication might come in handy. Division may also come in handy. Quite common are percentages and percentage points, and I'll go into detail on the difference between those two later in the presentation, but you should be very comfortable with percentages if you want to be able to perform to your best in the exam. And sometimes ratios are in there as well. So for every 2 of one thing, there's 5 of another, for example. So getting a bit of familiarity with ratios can also support you. However, there's a lot of things that you might be prepared for that are less important. So the first thing is complex financial terms. So you're not going to be asked about net profit or gross income or something like that. If you are, there's a slight caveat that from time to time you may be asked about these things. If that's the case, it will define that term. So it will tell you this is worked out as the difference between these values, or this is the sum of these values. But you can't really prepare for this exam by learning a bunch of financial terms. Your multiplication tables, so you're not expected to know kind of off the top of your head what 6 times 7 is, for example. Now, obviously, having a kind of quick understanding of that may help you estimating some things, may help you kind of quickly put things together. But it's certainly learning your multiplication tables off by heart is not going to be the most productive use of time in preparing for your exam. Algebra, so we're not going to have any 9x plus 3 equals 15. We're not going to have that kind of complex mathematics. It's about reasoning with information you know rather than the skill of algebra. Similarly, things with shapes, so geometry and trigonometry are not things that are going to be tested here. So understanding of those is going to give very little value. Long division. Now, from time to time, you might have to do some division, but you will have that calculator to hand. Or you'll be able to estimate to get those values smaller, or you'll just not have huge long numbers to divide. But learning how to actually do long division by hand, and long multiplication actually, is unlikely to be beneficial. You're not going to be given fancy infographics, so the sort of basic charts and tables I show you are going to be about the extent of complexity. We're not going to have one of these, kind of, you see them a lot in marketing, where they have 1,000 people and they have those represented by little stick men or something like that. Something a bit more graphical and a bit more interesting to look at. The EPSO Numerical Reasoning is going to be based around kind of reasonably basic tables and charts. And there won't be a strong verbal component. So you're not going to be, the question's not going to be along the lines of a train leaves the station at 7:30 and it's travelling across 2 time zones. The understanding that you need to have for your numerical reasoning comes from interpreting the tables and the charts, not so much from interpreting the question. So you might have a sentence or maybe 2 maximum as to ask you the question. So here's a table that could be used in a question, and we've presented some questions at the bottom and how we would measure those. So, for example, if you're asked what is the total population of Bulgaria, Croatia and Greece, I'll just tell you it's this information here that you'd use, population, but this word total clues you in that it's addition you're going to be using as a skill. The next question is what is the difference between the population of Bulgaria and Croatia? So here you would be using subtraction. So what is this minus this? Now I'm using reasonably straightforward examples so far, but being able to very quickly pick up exactly what it's asking for, noticing keywords like difference or total or sum or what is the increase, that can really help you very quickly work on this numerical reasoning part. So the next question is a little bit more tricky. Based on the above table, how many people between the ages of 15 and 64 are employed in Croatia? Well, these are percentages here, and these are our key pieces of information. So here we'd actually be using multiplication, and the multiplication would be using percentages. So a few skills here, understanding that you need to use multiplication and understanding that these are percentages that you're going to bring into that. And the final, very tricky numerical reasoning question, how many times more 15 to 64-year-olds are there in Greece than in Croatia? So the key parts here are the population, the proportion that are 15 to 64 years old, and what you'd be doing is multiplying these together, as we did before, and then dividing one by the other. So this is for how many times more. So there's probably, I think there's about 3 times more, a little bit less than 3 times more in Greece than Croatia, I think would be our answer. If it had said how many more, rather than how many times more, but how many more 15 to 64-year-olds, that would clue you in that that final step would be subtraction instead. And that's because you'd be looking for the sort of absolute difference rather than the relative difference, which looks to be around 5,000. Now in this case, if you actually saw your answer options as well, I think they would help you out in terms of figuring out what the correct answer is. So whether you're looking for about 3 or about 5,000, your answer options would also give you a bit of a hint there. But notice how that one additional word, how many times more versus how many more, does change the content, the final calculation quite significantly. So I want to talk now about calculation. Now I don't have, I guess, that much advice, because this is kind of a skill that that you just need to practice a lot. You should be using a calculator, and what I would recommend is writing down your progress as you progress through the question. So instead of working out the question and then writing down the answer, ticking the answer at the end, write down every step you make. And that's because if you make a mistake and you don't have the exact answer you expect, so you come up with an answer, you think you've known the route to get there, you're confident with that, but it doesn't match up with one of the answer options, you can always go back and check it again. One thing I should say is that sometimes when crafty test writers are putting together the questions as well, we will think about things that people will commonly misunderstand, common miscalculations, common errors, so multiplying by the incorrect number, for example. And we will use those to create false answers. So it's always a good idea, if you have time, to double check your answers or use estimation to check them. And that's because just because you've got the correct answer doesn't guarantee, just because you've got an answer that is one of the 5 available, doesn't guarantee it's the correct answer. It's very likely it is if you've managed to work it through accurately, but do be aware that is a potential falling point. There could be multiple routes to an answer as well, so there may be different ways of working out how to get to an answer, and you might have a clever, quicker way. You might be able to even use multiple routes if you've got plenty of time. You might be able to use multiple routes to check your answer. And the final point is to take care with percentages. So a percentage, a score less than 100%, is effectively saying that this number will be lower. So you're effectively, so 50% is effectively 0.5. It's half of the score. It's quite easy to get your percentage points in the wrong place and miscalculate an answer. In fact, even when we were putting together this webinar, we had a decimal point in the wrong place, and we were unsure. We had one of our answers incorrect while we were working through it, and it was very confusing. So it's very easy to make that mistake, and that's why you should be very careful about your units as well. Sometimes you will be presented with answer options that will give you kind of 38 million versus 3.8 million, and if your decimal point has wandered somewhere during your calculation, you might get that you might get your final answer incorrect. So a few calculations here, just to demonstrate. So which product had the highest total value of sales in 2016? So completely discount the 2015, and you have 3 products. So this is essentially 3 different calculations. So 290 times 150 euros, 482 times 80 euros, and 230 times 160 euros. Now what we would recommend, as I said, write down your answers. So you're not going to work out product A, try and remember it in your head, work out product B, try and remember it in your head, work out product C. I mean, you can do that, but you're making it more difficult for yourself. So work out product A, write down your answer, work out product B, write down your answer, work out product C, write down your answer. Makes it easier to check them as well. And it's, you know, this question has become something that might be a little bit overwhelming to just 3 lots of simple multiplication. So 3 things you can just punch into your calculator and figure out the correct answer. I want to talk a little bit about percentages versus percentage points now, and I'm trying to illustrate a couple of principles with this question, or with this series of questions. So a percentage point increase is kind of a direct number. It's a subtraction or an addition. So the percentage point increase between 20% and 30% is how many step changes you need to make to get to that second number. So 21, 22, 23, 24, etc. It's 10%. That is percentage point. Percentage is the relative change. So we know that that this is increased by 10 percentage points. To work out the percentage increase, we need to work out how 10 percentage points works in relation to 20%. And you may be saying it's about half. You're right, it's exactly 50%. So the key concept there, this is 10 percentage points, but it's actually 50 percentage points increase because you're adding on 50% of 20% to that 20%. So move back, what is the percentage point decrease between 2013 and 2014? This is, again, 30% minus 20%. That gives you a 10% decrease, a 10 percentage point decrease. And again, to work that out, now you need to work out 10% as a fraction of the starting value here, 30%. So your 10 percentage point drop is actually relatively a 33% drop of your original figure. Now, one thing that's interesting to note, so you may have got your head around percentage points and percentages. One thing that's interesting to note is that because each new percentage calculation is relative to the original figure, the increase and the decrease are actually different. So it's gone from 20% to 20%, but it's actually started with a 50% increase, and then it's dropped 33%. Why is that? That is because every percentage calculation works from an original figure. So both of these are 10 percentage point changes, but a 10 percentage point from 20% is a 50% increase, and 10 percentage points from 30% is a 33% decrease. Now, this is a very sneaky example. It's engineered to be very confusing. Often what you'll have is you won't have these percentages here. So this will just say 20, 30, 20, and you just need to, and then it's obvious that what a percentage difference is. But I do want you to be aware of percentage points and percentage differences. Another example now, and this is to show that there are sometimes different ways you can get to the answer. So what is the total value of product sold across all 4 cities? Well, one way you could work that out is working out how much product was sold per city, and then totaling up that column there. The other way you could do this, excuse me, is to figure out that actually, because this is the same, the average across these will be the same as well. So you only really need to multiply 152 euros by this total here. Now, both of these routes will give you the same answer. I'd say the second route that I've just described, I might be a little bit uncomfortable about using that myself if I wasn't kind of, if I didn't know the question inside out. So neither way is right or wrong, but just look for kind of what you're comfortable with. And as I said, sometimes you can use a second method to test that your first method was correct. So I'm going to talk now about estimation. So estimation can help you save time on some questions. It's a powerful method of working out answers quickly. Sometimes estimation won't give you an exact answer, but it will still narrow down your options. So sometimes a very quick look at the numbers and adding them up, adding very round versions of them up, can quickly tell you what, help you eliminate 3 of the potential answers. One thing you can do is look at all your answer options, and if they're very close together, estimation might be less effective, but if they're very far apart, you know that there's not going to be a huge, you know that estimation is going to tell you, help you hone in on the correct answer very quickly. When you're estimating, it's very useful to note whether you're rounding up or rounding down as well, because that can give you an indication of whether your ultimate answer is going to be higher or lower than your estimation. We've got 3 different estimation techniques shown here. The first is rounding off large numbers. So in the example here, instead of multiplying 3,982 by 2, we multiply 4,000. So we know the answer is going to be around 8,000. Fractions, so sometimes you can, for example, turn percentages into fractions very easily. So 68.1%. I would, if estimation was appropriate, I would just use that as 2/3, because 2/3 is 66.7%. This is a very close approximation. And something that's less useful or less frequently useful, but can still be very useful in particular questions, particularly with addition and subtraction, is using the last digits. So in this example, we know that 1 plus 7 equals 8, so we know our last digit for this sum is going to be 8. Even if we can't work out the rest of the answer, that still might help us eliminate answer options and give us a good chance of picking the right answer from those remaining. So here's a few quick examples of estimation. So the first question is, what is the total sum of column A? And we've used estimations here, firstly to make these numbers nice and round, 150, 200, 250, 475, less nice, but and secondly, we've added those together. So 150 plus 200 plus 250. Now you may already recognize that these 3 numbers added together would make 300. So this is 150, 350, 600. Then you add the 475 on the end, and you have a number that's round about 1,075. So that will help you narrow down to 3 answers. So you've already gone from, if you're just going to guess now, you've already gone from a 20% chance of getting it correct to a 33% chance of getting it correct. What you can also do with this, though, is look at the sum of the final figures. So 6 plus 3 will give you 9, plus another 9 will give you a number ending in 8. Add another 8 and it will give you a number ending in a 6. So by adding these together, working out your final figure. Now if you're working out the full sum using kind of proper long addition, you'd carry this 2 and add it onto this column, but we're not going to do that here. We're just going to take this 6 and say, well, our final figure has to be 6. Now you can see we've used a couple of estimation methods, and the first one has let us narrow it down to the final 3 options, and the second one has allowed us to narrow it down to just B and D. So we know that the final answer will be D. Another example is with fractions. So what is the total sum of column B? Looks like a reasonably difficult question to me, but because I know these can be very, very easily estimated, I know that it's very easy to actually quickly work out that you're going to be very close to 1. Now I talked about rounding up and rounding down. In this question we have, what is the total price of all products sold in City 1? So we know it's going to be about 150 times about 2/3. So we know it's going to be about 100,000 euros. But which answer is right? It could be either of those. Well, we know that we've rounded down a bit here, and we know that we've rounded down a bit here. So that tells us that our approximation is going to be a little bit below the answer. Ooh, gone backwards. And here you go. So we know that the final estimate of 100,000 is a bit lower than the correct answer. So we know that the answer must be B, 103,360 euros. One question you might have, and there's no golden rule for this, but I'm going to try and give you some guidance, is whether to use calculation or estimation when you approach a question. So here are some pointers that can help you see which is more appropriate. How different are the answer options? So if they're very, as I say, if they're very packed together, then you're not going to, then estimation may well not work. If there's huge differences, even between sets, it might help you narrow down quickly. Do you have time for estimating or calculating, or to do both? As I said, charts themselves, if you can't read the exact numbers off them, it makes exact calculation impossible. So you're going to be estimating anyway, so you might as well kind of make all your numbers nice and round. Sometimes words can give you that indication as well. So if it says approximate, what is the approximate population, or what is the rough ratio that of these two figures, then you know that estimation is likely to work. Some of it can be very much a timing thing as well. So if you've got plenty of time, then it's probably worth trying both of those methods out and making sure you're correct. As I said, estimating can help you narrow down your choices quite often, and it can also help you to make sure your answer is correct even if you calculated it. So it can give you an idea of sort of ballpark your answer should be in. So I'm going to give some overall tips and tricks. Firstly, don't be too overwhelmed. When you see the table for the first time and you don't know exactly what's going on, everyone is seeing these tables for the first time, and the key thing to do is to take a moment and think about what's in that table. And that is part of the skill they are measuring, is the fact that you can look at and digest this table. It's not something that people can do instantly, it's the reasoning skill there. Look at the question and relate it to the table or tables to help you figure out the answer. Sometimes common sense can help you work out your answer. So if I've worked through a question and I work out the population of Germany to be 80,000 people, chances are I've made a mistake in my calculation there. I've probably dropped the thousands because it's more likely to be 80 million than 80,000. So sometimes, that's a very crude example, but it gives you an idea of the sorts of things that can help. Similarly with percentages, if you know something is likely to increase, so if you see all your populations in the question are increasing, and you come out with a negative number, a decrease, then you know you've done something wrong. So you can apply a bit of background understanding to help you. As I mentioned, just because you calculate an answer, that doesn't make it the correct answer necessarily, because we may have thrown in tricky questions to make things more difficult, picked on common mistakes that people will make while calculating the answers, or in terms of choosing what reasoning, what method to use. You can often rule out clearly incorrect answers very quickly, increasing your chance of getting the correct answer. You may not need to use all zeros. So if you're working things out in thousands, for example, sometimes you can drop the thousands and only reapply them at the end of that question. For example, if you're looking for the difference between two populations, instead of looking at 80 million versus 75 million, you could just look at 80 minus 75. That gives you 5, and then you know the unit essentially is in millions. And practice is very important. I guess that would be my strongest take-home message, is practice as much as possible. But try and figure out what things particularly you struggle with. So if it's the interpretation of the data, then spend time doing that. If you really struggle with percentages, spend time practicing your percentages. And when you practice, try to simulate assessment conditions as closely as possible. So give yourself a time limit. Try and do it in silence if possible. If you can do lots of questions back to back, as you will have to do during your actual EPSO examination, then do lots of questions back to back. But try and give yourself those 2 minutes per question. So that is the end of the beginner webinar. As I mentioned at the beginning, there's a pro webinar where we're going to take all the skills that I presented here and put them into practice. So there'll be example questions which will base around lots of the principles we've discussed. There'll be voting, so you can work through these questions with me, and there'll be an opportunity to ask questions to myself and Lenka, who will be able to answer the questions either live, or we'll also send out a discussion document afterwards.